Okay, so in this last example, you're going to notice that we're going to have a little bit of an extra step because as you can see in our system of equations, we have negative 4x plus x equals 6 and negative 5x minus y equals 21. Neither of them are equal to y or to x. So this is where we're going to have to go back to lesson 1.2, where we have to write one of these equations in y-intercept form. So I'm going to choose the first one, negative 4x plus y equals 6, to write in y-intercept form. And the only reason why I'm choosing that one is because I noticed that in front of my y, it is a positive number. So I'm not going to need to divide by negative 1 at the end. So when I rewrite this in y-intercept form, I'm going to move the negative 4x to the right. When I do that, it now becomes a positive 4x. So now my equation is y equals 4x plus 6. And I still have my second equation, negative 5x minus y equals 21. So now, just like the last example, we are going to substitute in 4x plus 6 to where we see y in this equation. So when I do that, I now have negative 5x minus. Now, again, this is a little bit of a tricky part because I want you to remember that that minus means that there's really a negative 1 there. So I'm going to write negative 1, and then in parentheses, I'm going to write 4x plus 6 equals 21. You need to remember that this 4x plus 6 always has to go in parentheses because we're always going to distribute whatever number was in front of the y to the rest of this equation. So now let's simplify this and solve for x. So the first step is to distribute that negative 1. So when I do that, I still have negative 5x, but now I'm going to do negative 1 times 4x, which is negative 4x, and negative 1 times 6, which is negative 6, equals 21. Then I'm going to combine like terms. I'm going to combine negative 5x and negative 4, which gives me negative 9x minus 6 equals 21. Now my goal is to isolate that x, meaning get it by itself. So the first thing I'm going to do is add 6 to both sides of my equation. When I do that, I'm going to come right up over here and write that. I'm left with negative 9x equals, and 21 plus 6 is 27. My last step is to divide both sides by negative 9. And so now I have x is equal to negative 3 because 27 divided by negative 9 is negative 3. So that is the first part of my solution. Just like all the other examples, I need to plug in to find the second part of my solution. I'm going to plug in this part of the equation where I've already written to y equals because it's a little bit easier for me to solve because I already have it set equal to y. So I'm going to do y equals 4 times negative 3 plus 6. When I do that, I have y equals negative 12 plus 6, and y then equals negative 6 because negative 12 plus 6 is negative 6. So that is the solution to both of my equations, meaning when they are both the same. Now, I do want to double check before I move on to make sure that this works in my second equation. So I'm going to plug in negative 3 and negative 6 where I see x and y in my second equation. So negative 5 times negative 3 minus a negative 6, when I solve that, should be equal to 21. But let's make sure. So negative 5 times negative 3 is a positive 15. When I have a negative and a negative together, that becomes a positive 6. And let's check. 15 plus 6 is 21. So since that does equal both equal 21, that means that this solution works for both equations and it's a solution to my system of equations.